So today is a car marketing session, which doesn't mean we're going to waffle on for ages. We're going to try and give you useful information as quickly as possible. And what we're going to do is build this mains breaker or large breaker prop. And since I'm not a proper prop maker, what I really want to bring your attention to is the automation in the prop, because that's our speciality, automating props. And in this particular case, this is the central module we're going to use. Let's just get it powered up on this USB battery, and then just let's let it go through its boot sequence so we can see what's going on. Obviously, I've pre-programmed this one and it's going to jump onto the network and all the rest of it. And you can see it's come up with 0 volts and 0 amps, and that one's doing something different. But if we go here, wake up this iPad for a second, and we can send this one off to that voltage, that current, and we can see that it's gently animating, and that's just to create a little bit of background interest. We can push the current up a little bit more and we get that orange look, and that's, you know, in cinematic terms, it's designed to show you that you're near the limit and you're creating a bit of tension because something bad might happen. And if we take it all the way over, it's going to trip this breaker. It's actually going to trip that one in the background, so we might hear that. So let's take it up to 1100, and bang, that goes, and then you'll see this goes back down to 0, which is as it would do. The little bit of delay in there is real, because in the real world, these breakers have to measure and then report, measure, then report. Anyway, we can reset the breaker, reset the current and voltage, and away we go. Now, in all that lot, I don't know if you noticed, I'm going to check for myself. I'm actually going to issue a trip. You'll see that this servo is moving for the trip and the reset. Well, I've got that tripped at the moment. Let's reset it. And it's this combination of the control module and this movement that's going to allow us to build this prop. Okay, so the first part of this build is going to be to pop this servo onto this back plate here, which is just going to need a little bit of a push, I think. Let me just check that this is the right servo. 85 mg. Okay, as with all good build videos, we've had a little break straight away to find out what went wrong. So this is the original one that we've made, and that's built with an HS 81 servo, and what I had hanging around was a HS 85 MG, which is a metal geared servo, which is a much stronger servo. So what we're building this with is a stronger servo than we need. Now, somewhere around here, there is a small, there it is, small glass pot of screws. So we'll start off with the 2 reasonably small screws, and I'm going to use those here just to screw the servo back into this base plate. And we're going to talk a little bit about this base plate shortly. Actually, it doesn't need to be ridiculously tight. There's that one, and here's the other one. So we're just getting the servo in place, and then the servo lead will go off, and just like we saw earlier, it will connect to the control system. Right, okay, so we have the servo on the back plate, and then we have these 2 lever arms, and they're slightly different. This lever arm's got this shroud around it, and this one hasn't. The one with the shroud arm around it is the first one we want, and we're going to put on here, and this runs really smoothly. What I've done with this earlier is actually I gave it a little bash of WD-40, and then to hold that in place, we've got one of these, and again, we're just going to put a small 3mm screw through it, and I'm not going to tighten it up fully. I'm just going to bring it to a reasonable level of tightness. All I want is it not to come off. And then I'm going to talk about the next 2 bits we're going to put on, which are quite interesting. Right, let's just get this to, let me just show that to the camera. Not particularly. Yep. So that's still nice and loose. Then this bit here, whoops, this bit here, this is made out of PETG. So actually, while we're doing this video, it's probably worth talking about the different types of plastics we've used and on why we use the different types of plastic. The components you've seen here are made out of PLA, polylactic acid, and the beauty of those is that they're biodegradable, and this is made out of PETG, and the beauty of that is it's recyclable. And what we're going to do is we're going to get this little component here in here, and I happen to know that that is going to need a 2.5mm screw. So where's my collection? Okay, so at this point we have the PETG spring in here, so if we pull it out of the way we can see that this thing falls down, and if we pull it up the top we can see that it clicks in, so that's quite good. So the next stage is to get the servo control arm in, which is here, but we can't just put the servo control arm on just as is. What we really need to do is to get it plugged up into the module first. So let's get that right. We can remind ourselves what it is. Here we go. We get it plugged up into the module and get the module on. And the reason I'd like to do that is because I want the servo to settle in what should be its center position. So I've connected that, so that's ground power signal, that looks good. Let's get some power on it. This little thing here is going to go through its cycle. Oh, got some. There we go. Right, okay. So we now know it's in its center position. So at this stage, we can we'll just unplug it from there. That's fine. So we can put this now in the central position. Near as damn it, doesn't matter too much for what we're doing, but we can put it there. Push the servo in there, and then this is the servo retention screw. Oh, what's my favourite? Wants a smaller screwdriver. And for our next tricks, we're going to put the two flexible, these are really flexible, let me just show you, these are really flexible parts. So these are made out of TPU. So this plastic is TPU, and it has the advantage of being functional, flexible. It's actually very good for things like chemical wear and all the rest of it. But in terms of sustainability and all the rest of it, it's not particularly good because you know, it doesn't recycle in the same way that the other stuff does. But that, for what we're doing, is not particularly important. What's important is the fact that it's going to be flexible. So this one's reasonably straightforward. We're going to screw this in here on this 3mm. Let's take a little bit of doing. Again, I don't want to make this too tight because at the end of the day, I want this to flex. But what I do want is I want the TPU part. Make sure that doesn't go, yep, about there. I want the TPU part to roll round that shroud there. And let's just put the breaker in a more of a tripped position so you can see what it is, see what it's like. And then this is going to screw into the servo there. And you know what? Out of fun, what we could do is bring the whole thing on, give it a chance to boot up. Let me see if I can angle that way. And there is, in fact, a reset touch here that may work. And as you can see, that pulled that all the way up and pulled it into position. Okay, so our next stage is to go put the trip TPU pull in. There we go, that's going in there. I don't want to put it in there too tight, just want to be quite nice. And I'm just going to refer to the reference, which is, oh, aha, this is important. It doesn't go all the way along, it goes 2 in, so it's there. Yep, so it's here, there. Oh, talking about code, the way that we've written the code is that whenever the prop is at rest, there is no power going to the servo. The power's only going to the servo when we're actually doing something. So let's try a trip. Yep. So the important thing about that to watch there is that when it pulls it down, we can see that it's pulling it very clear of this. From the last shot, you may have noticed that we've nipped off and we've shortened this arm of the servo because we realised it was going to clash with the next item, which is putting the servo in. Not putting the servo in, putting the spring in. So join us at the stage where we've just put the spring in and we're going to do one of the first integration tests. And I suspect this test is going to fail because you might remember that this has got an HS71, this has got an HS85 with metal gears, and I think the throw of these two servos is slightly different. So the thing that I think is going to work is the trip. So let's try the trip. So the trip's worked, and you can see that it's pulled down nicely. That's worked nicely. I might change the position of that so it pulls down even further. Yes, I am going to change the position of that so it pulls down further. But the reset, I think, is going to pull the servo too hard. But let's see what happens. No, it worked. How cool is that? It's working. Ah, well, there you go. So, having built our mechanism, the next stage is to screw our mechanism, or get the base plates, and even do, if we can see that, even set the voltage, set the current, reset the breaker, take it up over the limit, and check that it definitely breaks. So that's a cracking thing. Right, we've done that. What's it called? I think it's called a Greystone switch. And they're basically very nice switches that are used in the world of gaming keyboards. And you can get like 100 of them for about 36 quid. And for us, they make things that are very tactile, that actually feel good when you go to press them. So anyway, here we go. We're nearly up to the last screw here. There's our touchscreen in place, and we're kind of ready for the final dressing, which is going to be this item here, which is giving us the, if you like, the full look of the breaker. Right. Oh, for reference, there's nothing special about this. We're just powering it off standard USB batteries because they're easy to get at. Let's see what happens. Are you going to behave yourself? Well, you seem to be switching on. Ha! Well, what we do confirm in all that is that the touchscreen is still working. These were the greywood switches that I was talking about, and as I say, I think this box cost us 36 quid, and you see the feel of those is absolutely brilliant, and that's because they're used on gaming keyboards, so it gives a really good feel. Anyway, just to finish this off, I'm just going to pop these caps in the end of here, which are just going to strengthen the whole crossbar. And on this one, I found that we did everything too quickly. So this one we're going to just do slightly more gently, slightly slower, and just put a little bit of glue in each one of these corners here. Not as much as we did before, because actually it doesn't really need that much. And it is so tempting, isn't it, to check that the thing works still. I'm tempted. I can't resist it. Let's just see whether we're still connected. Reset the breaker. The answer is it's working. Take it over voltage, and that should go to 0, working. Reset the breaker, set the voltage, set a decent current, and let the thing run by itself. Anyway, so there you are, and there it was. We've built this prop breaker. As I said earlier, I'm not a proper prop maker, and I'm hoping that you, as a proper prop maker, can look at this and say, well, of course we would weather that, of course we'd look more at the references and all the rest of it. But the point of putting this together was to show you the automation. So what we've done is we've taken the code that runs on the set wide net and we've dropped it into this little industrial touchscreen module, and we've got it to drive the servo. We've made a mechanism that looks reasonably realistic, and actually when it's in a box it makes quite a satisfying thud. And bringing the whole thing together, I think you can see that if you were putting together a production where your protagonist is gradually using more and more power, and they get to a point where they've overcooked it and everything breaks and stops and puts our protagonists into their pit of despair for them to work themselves out again, I think you'll find that this is going to do the job. Anyway, there you are. There it was. Thank you for watching. I hope you had a good cup of tea or coffee while we were doing it, and we will see you in the next one.